If you had to protect an industrial plant tomorrow, where would you begin? The firewall, the PLC, or the process? Start with the process. In operational technology, cybersecurity protects physical operations, not only data. This video gives you a practical 6-rung roadmap from zero knowledge to trusted OT cybersecurity practice. At every rung, you will learn a concept, build something safely, and create evidence that proves what you can do. An OT cybersecurity expert is not simply an IT specialist who memorized PLC acronyms. Expert practice combines industrial processes, automation, networking, cyber defense, risk, safety, and communication. You must understand what the system controls, identify credible risk, design a safe improvement, and explain the operational consequence. A course can validate knowledge, but expertise is earned through sound decisions and real cross-disciplinary experience. The wrong approach is certificate soup, random courses, tool names, and attack demonstrations with no dependency order. Use a capability ladder instead. First, adopt the OT mindset. Then build digital foundations, understand controls, learn architecture and protocols, practice defense in a safe lab, and finally, earn operational trust. An IT professional and an instrument technician may enter with different strengths, but both climb the same ladder. Rung 1 is safe work. A routine IT action, such as scanning, rebooting, or patching, may interrupt a fragile controller or remove an operator's view of the process. Never experiment on production equipment. Follow plant SOP, permit to work requirements, authorization, change control, backups, rollback plans, and define stop conditions. Your first proof artifact is a 1-page checklist explaining how an OT cyber task will be performed and reversed safely. Next, learn how computers communicate. Build working knowledge of Windows and Linux, IP addressing, subnets, switching, routing, VLANs, DNS, TCP and UDP, authentication, logging, virtualization, backups, and firewalls. In an isolated lab, create 2 small networks, route traffic between them, capture packets, and explain the source, destination, protocol, port, and firewall decision. If you can troubleshoot the path methodically, you have useful foundations. Now learn what the network controls. Trace one complete loop. A pressure transmitter measures the process. The controller reads the signal, logic calculates an output, the operator sees the value, and a valve changes the physical process. Learn PLC, DCS, SCADA, HMI, historian, remote I/O, alarms, interlocks, permissives, and safety systems. Your proof is a diagram that connects every cyber asset to a physical consequence. Then learn to see the whole plant. Use Purdue-style levels as a communication model, not a perfect map of every facility. Understand enterprise and OT boundaries, the industrial DMZ, jump hosts, remote access, zones, conduits, and critical dependencies. Recognize common traffic such as Modbus TCP, Ethernet IP, Profinet, OPC UA, and vendor engineering communications. The goal is not memorizing ports. It is understanding who must communicate, why, and with what consequence. Trust boundaries are invisible, but every packet crosses one. A historian request may be permitted from the DMZ to a specific server. A direct engineering command from the enterprise network to a PLC should be denied. The firewall is not protecting a colored box on a diagram. It is enforcing an approved relationship before a digital message can create a process action. Good architecture makes permitted paths explicit and unnecessary paths impossible. Quick check. A vendor needs temporary remote access to a PLC. Which option is safest? Expose the PLC directly to the internet. Allow permanent remote desktop from the office. Disable the firewall, or use approved, time-limited access through a monitored jump host with multi-factor authentication and change control. Think about it. The correct answer is the monitored jump host path. Safe access is approved, limited, attributable, observable, and removable. Local plant procedure and vendor requirements still govern the work. Build your practice environment with systems you own or are explicitly authorized to test. Use virtual machines, an offline industrial simulator, simulated PLC and HMI traffic, provided packet captures, and tabletop scenarios. Begin with passive observation. Record normal behavior, create one authorized abnormal event, and compare the evidence. Never scan, exploit, fuzz, change firmware, or write to a production controller without an approved method and operational coordination. Your first portfolio project is a normal traffic baseline. Draw the lab architecture, inventory the assets, capture a short authorized packet trace, and document which devices communicate, how often, and with which protocols. Then write what would look unusual. The output is not a screenshot of a tool. It is a clear diagram, packet notes, assumptions, and findings that another technician can verify. Your second project is segmentation validation. Permit a defined historian flow through the firewall, but deny a direct enterprise to PLC connection. Document the business need, source, destination, service, owner, test method, rollback plan, and expected process impact. This converts a firewall rule into a defensible engineering decision. Strong OT security is not the maximum number of blocks. It is the minimum communication required for safe operation. Your third project is an offline incident scenario. Correlate an engineering workstation login, a controller project change, a network alert, and an operator alarm. State what is confirmed, what is only suspected, and which physical effects are possible. Then recommend containment with operations. Disconnecting the wrong system may create a more dangerous state than the incident. Preserve evidence, maintain safe control, and recover from tested backups. Move from learner to trusted practitioner by working with operators, instrument technicians, control engineers, network teams, safety personnel, OEMs, and system integrators. Shadow real workflows. Join controlled reviews and tabletop exercises. Own small supervised improvements before leading assessments. Specialize later in architecture, monitoring and response, governance and risk, secure automation, or product security. Certifications can organize study, but your portfolio and operational judgment prove capability. Remember the route. Protect the process. Understand the network. Trace the control loop. Control the trust boundaries. Observe safely. Prioritize by consequence. Earn operational trust. Start with one process, one control loop, and one isolated lab. Map it, observe it, protect it, and explain it. Then repeat with larger systems. You become valuable when you can connect a network event to a process consequence and improve security without creating a new operational hazard.